Hello everyone, welcome back to Pre-Algebra with Miss Betsy. Today is going to be a very easy lesson because what we're going to be doing is multiplying integers, which means that we're going to be multiplying signed numbers. And if you look in the text, they make it seem to be rather difficult. We're going to see that there's nothing difficult about it at all, provided that you learn just some simple rules. Now, I'm coming to you today from our county library, so the background is a little bit different, and also means that I have an actual lame joke book that I'm going to be using for you today. If you are tracking along with me, however, we're using the same text that we always are, which is Pre-Algebra for Christian Schools, published by Bob Jones University Press. This is the first edition. If you have the second edition, you're going to have to flip all around with the videos because the two are not compatible as far as the way in which the book is laid out. And if you're not even using a BJU book, it doesn't matter. You multiply integers the same way regardless of what textbook you are using as your reference. So let's pray, see what sort of a joke I pull out of this book, and we'll get this video finished in short order. Father, I thank you for the rain that you have been blessing our land with over the past few days. Father, I ask that you'd continue to let the rain come to have an effect on the drought that we're in the midst of, and I thank you for your involvement in our lives. Father, I ask that you would be with the kids and the adults who watch these videos. Help them to comprehend the material and to be able to apply it effectively and correctly in their studies and in their lives. Pray this in the name of your Son, Jesus. Amen. I flipped through this book just a moment ago. Let's see how quickly I can find, it's the wrong book, that's the problem. Animal Quack-Ups, which is pretty much guaranteed to be about as lame a joke source as you can find. So what do you call two spiders who just got married? You call them newlyweds. So that's lame joke number one. Now, we are in section 4.5 entitled Multiplying Integers, and this is on page 126. And we're going to remember that integers are whole numbers and their opposites. Now the whole numbers, of course, if we had the set, let me get a reference here for how high I can mark on this board. Okay. The whole numbers would be the set that begins at 0 and continues on in a positive direction. So the whole numbers are 0, 1, 2, 3, and 4. And we said that the integers are the set of the whole numbers and their opposites. Now 0 is its own opposite. We learned that opposites are those numbers that are the same distance from 0 on the number line. And this was how we used set notation to indicate what the integers are. Now, we're just simply talking today about multiplying positive and negative numbers essentially together when there are no fractional parts, but the rules for multiplying integers are the same as for multiplying fractions or decimals as well. So just tuck that away in the back of your memory, back of your mind as we do this. So let's go ahead and see what the rules are. Now, if we're going to multiply, you know that there are two numbers that you multiply together. Those are called factors. The result of multiplying two factors together is the answer to a multiplication product, which is called to a multiplication problem, which is called the product. And let's just say that we have the numbers, the integers 2 and 4, and we're going to do a mix of multiplying positives and negatives together. So what do we have? We could have 2 times 4. We could have a negative 2 times a negative 4. We could have a negative 2 times a positive 4. And we could also have a positive 2 times a negative 4. So these are the only 4 possible ways that you can multiply together two numbers that are positive or negative. And you'll notice that these first two pairings right here, the signs are the same. And you'll notice with these last two pairs of multiplied numbers, but these have different signs. In actual practice, what you get down to, even though it involves absolute value of numbers, technically, what you're doing is you're going to look at the two numbers that you're multiplying together. You're going to look at the factors. And you're going to just sort of put out of your mind for the moment whatever sign is in front of it and just multiply the positives. What is 2 times 4? 2 times 4 is 8. 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 But when you multiply integers together, you have to take into consideration the fact that you have positive and negative signs. You guys already know that a positive 2 times a positive 4 is a type of multiplication that we do on a daily basis, and that you end up with a positive result. What you're also going, and what I want you to notice is the signs are the same. Positive times positive gives us a positive product. You also have the same thing if you multiply a negative number times a negative. If the signs are the same, the answer is positive. So if you have the same signs, answer is positive. And what is the answer to a multiplication problem called? The answer to a multiplication problem is called a product. So the rule that we're talking about now, the definition, is that when you multiply together two factors that have the same signs, regardless of whether they're both positive or the integers are both negative, when you multiply two factors that have the same signs, the product, or the resulting answer, is always going to be positive. Take it to the bank, it's not going to change. God doesn't change. The answer to a multiplication problem involving integers that have the same signs doesn't change. It is always going to be positive. On the other hand, now we have a negative 2 times 4, then we have a 2 times a negative 4. And we've talked a lot about the commutative property of addition and multiplication. And what's that commutative property tell you? It tells you that it doesn't matter what order you multiply factors or the order that you add together addends. You're going to get the same result. Now, remember, the commutative property does not work for division or subtraction, but it does work for multiplication. So, we have these sort of in the same sign, but we actually have put a negative 1 in there, so by putting the negative 2 or the negative 4, we're really dealing with the commutative property. But what I want you to notice is that you have different signs here. And this, once again, God doesn't change. The sign of a product when you're multiplying together differently signed numbers doesn't change either. It is always going to give you a negative result. If you have one of your factors negative and one of your factors positive, the product will always be negative. Period. End of story. So once again, answer is negative. Always and forever. Take it to the bank. And the answer here to a multiplication problem is called the product. So let me get out of the way here and you see 1, 2, 3, 4. Positive 2 times positive 4 is 8. Negative 2 times negative 4 is also 8. The signs of the factors are the same. Your product is always positive. Over here we have negative 2 times 4. We have 2 times a negative 4. You have differing signs in your two factors. The product, or the answer, is always negative. That will never, ever, ever change. And that's all that's involved in multiplying integers. So when you're looking at your homework for this section, and it talks about absolute value because it's the opposites and distance from 0 and negatives, you don't have to worry about that. We have limited time to be able to cover the material that we're studying, learn what I just showed you, and you will never, ever have a problem multiplying signed numbers. So let's look at the skill check on page 127. And we have 9 times 8. We have -4 times a -3. We have -5 times a -2. We have 6 times a -4. These are problems 1 through 4 in the skill check, and it doesn't even want you to say 9 times 8 is 72. It wants you to tell them, is the product positive or negative? Signs are the same, so it's going to be positive. Signs are the same, it's going to be positive. Here we have a -5 times the -2. The signs are the same. Your product is going to be positive. So I must have done something wrong. Okay, I made up my own problem here. -4 times the -3 is positive. What happens if I have -4 times a +3? The signs are the same. The product is negative. Signs are different. The product is negative. Signs are different. Product is negative. This will never change. If the signs of the factors are the same, either both positive or both negative, your product will always be positive. Simple, simple, simple section today. This is a nice break from some of the stuff that you have and from some of the things that will be coming before too long. Now, they say, number 5, 7 times 5, number 6, -4 times 3, number 7, -3 times a -9, number 8, -4 times 12, 9 is -15 times a -20, and number 10 over here is 13 times a -3. And I tried to go ahead and write these down exactly the way they're in your book because you have the multiplication indicated differently with raised dots, with parentheses. You have to be able, the only thing that's going to trip you up in this section, honestly, is if you think that you're adding or subtracting instead of multiplying. 7 times 5, they're both positive. Your answer obviously is 35. 4 times 3 is 12. Is that going to be a positive or a negative? It's a negative because the factors have opposite signs. -3 times -9, you have 27, and that's going to be positive because even though the signs here are negative, they are both the same. If the signs of your factors are identical, the product is always positive. I have opposing signs here, different signs, so that means my product is a negative, and it's a -48. 15 times 20, in your head, 2 times 15 is 30, add the 0 and you get 300. Is it positive or negative? It is positive because even though you have negative signs involved in the factors, they are the same, and their product is always going to be positive. Your last problem, 13 times a -3, it's not negative, it's not a 10. 13 times 3 is 39. Your product is negative because you have one factor positive, one factor negative. The product is always going to be negative. See, I know you didn't think I could do this fast, but I did. Now you can dance and tell me about it on Friday. If you have difficulties, send me a text. Otherwise, I'll see you in class.